Welcome to Algebra 1. The learning goal for this episode is how to solve one-step equations, equations that can be solved using just one operation like addition or multiplication. Let's look at some examples. We typically solve these equations by doing the inverse operation. Inverse is the math term for opposite of whatever we've done to the variable. Often on these simple equations you can quickly guess the answer. Our goal is to learn the process so that when we get to harder equations that we can't guess the answer to, we know how to solve them. So our goal in this problem is to isolate the variable x. Sometimes we say, get x by itself. So first, we determine what's been done to x. In this case, 8 has been added to x. We want to do the inverse or opposite operation. So first, we want to do the opposite of adding 8, so we're going to subtract 8. It's very important when solving equations to always do the same things to both sides of the equation. That's the only way to make sure both sides of the equal sign stay equal. So we subtract 8 from both sides of the equation. This gives us a solution to the equation with x being equal to -5. Now the great thing about solving equations is that we have a built-in way to tell if we did it correctly. We do that by checking our answer. The first step is to rewrite the original equation. Then we substitute in the answer we got, in this case -5, for the variable x. Then we simplify. Since both sides of the equation end up being equal, we know our solution was correct. Let's try another example. Again, our goal is to isolate the variable x in this case. We notice that x has been multiplied by 5. We're solving this by doing the inverse operation, so we're going to do the inverse of multiplying by 5 first. So our first step is to do the opposite of multiplying by 5, so we divide by 5 on both sides. This gives us our solution, x equals -9. Are we finished? Nope, we can check our solution by rewriting the original equation, then substituting in -9 for x, then simplifying. Our solution is correct since both sides of the equation are equal. In this third example, notice how the variable is in the numerator of a fraction. Recall that the fraction bar is another way to write division, so this is really telling us that the variable d has been divided by 7. We want to do the inverse or opposite of dividing by 7, so we'll multiply both sides of the equation by 7. Remember, anything you do to one side of an equation, you must do to the other side if you want the two sides to remain equal. When we simplify, we get -21. Once again, we check our answer by rewriting the original equation, then substituting in our answer and simplifying. Our solution checks. Example 4 looks a little more complicated, but we approach it the same way. Our variable y in this case has been multiplied by -3/4. So we want to do the inverse operation, so we divide by -3/4. But this is where our knowledge of fraction comes in handy. We know that by dividing by a fraction is the same as multiplying by its reciprocal, so we're going to rewrite this as multiplying both sides by -4/3. Now that we've seen this once, in future cases we can skip the step where we divide by the fraction and simply go straight to multiplying by the reciprocal. When we simplify, we get y equals -16. Now we check it by rewriting the equation, substituting in -16 for y, and simplifying. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you with a question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So, for this first problem, our first question is, what are we trying to do here? What we're trying to do is isolate f, or perhaps get f by itself. Your next question is, what operations have been performed on f? Seven has been added to f. So what should we do next? We should do the opposite of adding 7, so we're going to subtract 7 from both sides. Now what? We should simplify both sides by combining like terms. This gives us f equals -10. Are we finished? No, we should check our answer. How do we check our answer? We start by rewriting the equation. Then what? We substitute in our answer, in this case -10 for f, and simplify. Let's go through that process again. What are we trying to do? Isolate the variable m. What operation has been performed on m? It's been divided by -7. So what do we do first? We should multiply both sides by -7. Now what? Simplify. Our solution is -21. Are we finished? No, we should check it. How do we do that? We rewrite the equation. Now what? Now we substitute in our answer, -21, in for m, then simplify. Our solution works. Let's try one more. What are we trying to do? Get t by itself. What operation has been done to t? It's been multiplied by 4/3. So what do we do? Divide by 4/3, which is the same as multiplying by its reciprocal, 3/4. Now what? We should simplify. In this case, we can reduce our answer. We typically leave our answers as improper fractions in reduced forms in algebra, but you could write it as a mixed number. Now what? Check our solution. And how do we do that? We rewrite the equation. Then what? We substitute in our solution, -9/2. Now what? Simplify. Our solution checks. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here's the solution and the check. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move on to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution and our check. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve one-step equations. We did that by performing the inverse or opposite operation to both sides of the equation. Remember that you can always go back and replay portions of this video if you need to see it again.